Good morning, students. In last class, we have started about the chemical reactions of alkenes, and in chemical reactions, we have done some addition reactions of alkenes. Since alkene contain carbon-carbon double bond, that is why alkene shows maximum of addition reaction, and in addition reaction, the double bond is converted to single bond. So this is number 3 addition reaction of alkene, which is called addition of hydrogen halides. Hydrogen halide is represented by like this H6. I mean HCl, HBr, these are the example of hydrogen halides. Like this is one of the alkene, CH2 double bond CH2, which is called ethene, plus suppose you are reading HCl, and this is another alkene, 3 carbon, that's why it is propene, and you are adding HCl or HBr. Now in this two alkene, this is ethene. Inside the double bond, this side contains CH2, this side also contains CH2. Since both sides contain a similar group around the double bond, that's why this type of alkene are called symmetrical alkene. But this is one of the alkene around the double bond, this side contains CH2, this side contains CH3CH. This type of alkene are called unsymmetrical alkene. I mean here both the double bonded carbon contain two hydrogen, but here both the double bonded carbon contain one double bonded carbon contain 2 hydrogen, one double bonded carbon contain 1 hydrogen. So this type of alkene are called unsymmetrical alkene. In case of symmetrical alkene, there is no problem. You add hydrogen with 1 carbon and you add chlorine with another carbon, and the double bond will be converted to single bond. So in this type of case, if you add hydrogen with this carbon, it goes to CH3. And when you add chlorine with this carbon, it goes to CH2Cl, and the double bond is converted to single bond, which is called 1-chloroethane. So in case of symmetrical alkene, there is no problem. You can add hydrogen with 1 carbon and you can add with chlorine with 1 carbon. But in case of unsymmetrical alkene, when you add these hydrogen halides, then as you know, in this hydrogen chloride, H is plus, chlorine is minus. So in case of unsymmetrical alkene, you have to apply a rule which is called Markovnikov Rule. Markovnikov Rule. As you know, addition takes place always with double bonded carbon. Now the hydrogen will be joined with which double bonded carbon, and the Cl minus ion will be joined with which carbon. So that is given by the Markovnikov Rule. And according to Markovnikov Rule, the negative part of the addendum is added to that double bonded carbon atom which contain less number of hydrogen. I mean this double bonded carbon contain 1 hydrogen, this double bonded carbon contain 2 hydrogen. Since this double bonded carbon contain less number of hydrogen, that is why the negative will be added with this carbon. So according to Markovnikov Rule, in the addition to an unsymmetrical alkene, the negative part of the addendum is added to that double bonded carbon atom which contain less number of hydrogen. Otherwise, see, when you add chlorine here, then you will get the product as 2-chloropropane. But if you add chlorine with this carbon, you will get 1-chloropropane. But here 2-chloropropane is the major product according to Markovnikov Rule. So that is why when you add this type of acid to an unsymmetrical alkene, always you remember the negative is added with that double bonded carbon atom which contain less number of hydrogen, and the positive is added with that double bonded carbon atom which contain more number of hydrogen. That is why hydrogen will be added with this carbon, it goes to CH3 and the double bond is converted to single bond. This is called 2-chloropropane. So this Markovnikov Rule is applicable only in the addition of unsymmetrical alkene, and according to this rule, the negative part of the addendum is added to that double bonded carbon atom which contain less number of hydrogen. Now I'll tell you about the Markovnikov Rule. according to this rule, in the addition to an unsymmetrical alkene, the negative part of the addendum means what you have added, here HCl is added, that is called the addendum. The negative part of the addendum is added to that carbon atom constituting double bond which contain less number of hydrogen atom. So this is called the Markovnikov rule. In the addition to an unsymmetrical alkene, the negative part of the addendum is added to that double bonded carbon atom constituting double bonded carbon atom which contain less number of hydrogen. This is one of the alkene, CH3 CH double bond CH CH3. This is symmetrical or unsymmetrical alkene. This is one example of symmetrical alkene because this side around the double bond both the groups are same and both the double bonded carbon contain similar number of hydrogen. That is why this type of alkene are called symmetrical alkene, whose name is butene. So in this symmetrical alkene, when you add HCl, there is no problem. You can add with you can add hydrogen with one double bonded carbon atom. You can add chlorine with another double bonded carbon atom. You can add chlorine with this carbon also, There is no problem because this is symmetrical alkene. But if the alkene is unsymmetrical like propene, then you have to apply this Markovnikov rule. Now, why the negative is added with that double bonded carbon atom which contain less number of hydrogen? If you want to know about this, suppose this is your reaction. When propene is react with HCl, it produces 2 chloropropane. Why the chlorine is added with that double bonded carbon atom which contain less number of hydrogen? Why the Markovnikov rule is applied here? If you want to know about this, you know this is HCl. Hydrogen and chlorine contain one covalent bond. First time in the reaction, if you want to know about the mechanism of the reaction, the HCl will break like this and it will form H plus and Cl minus ion. So first time the hydrochloric acid will break and it produce one electrophile and one nucleophile, H plus ion and Cl minus ion. After production of this electrophile and nucleophile, they will attack to the substrate molecule. Our substrate molecule is propene. The organic compound is our propene. Now, which one ion will attack first time, the electrophile or nucleophile? Since here double bond is present, double bond means here electron density is more. Since electron density is more, that is why the positive ion, the electron deficient substance will attack to the double bond. That is why first time the H plus ion will attack to the double bond. So when the H plus ion will attack to the double bond, then this pi bond, this double bond, pi bond will break and these two electron, pi bonded electron will take the H plus ion from the acid. Now when this double bonded electron take this hydrogen ion, then this hydrogen will form a new bond either with this carbon or this carbon because double bond is present in between these two carbon. So you can join hydrogen now with this carbon also, That is why if you add hydrogen with this carbon, double bond will be converted to single bond now, you will get this product. Or if you add hydrogen with this carbon, then you will get this product like this. In this case, hydrogen is joined with this carbon, or in this case, the hydrogen is joined with this carbon. There is two possibility to getting the product. Now, after addition of hydrogen, double bond break and it will convert it to single bond. After converting to single bond, the valency of this carbon is 3, and that is why it will create a positive charge. And here also the valency of this carbon is 3, that's why it will create one positive charge. You know, the carbon, when it contains positive charge, they are called carbocation. And the difference between these two carbocation is, this is primary carbocation and this is your secondary carbocation. This is your primary carbocation and this is your secondary carbocation. As you know, secondary carbocation is more stable than primary. This is more stable because I have given there are 3 types of carbocation: primary, secondary and tertiary. Among these, tertiary is more stable than secondary than primary due to inductive effect. And since secondary is more stable, that is why this is the predominant product, and that is why you will get secondary carbocation more in the reaction due to more stability. And the Cl minus N, now already H plus is joined with alkene, now Cl minus is present here. This Cl minus N, since it is negative, this one is positive, it will attack to this carbon, and the chlorine will join with the middle carbon like this, and it will form the product. I mean, the negative is added with that double bonded carbon atom which contain less number of hydrogen. So due to this reason, due to more stability of secondary carbocation, the Markovnikov rule is coming. So that is why according to Markovnikov rule, when you add something with some unsymmetrical alkene, the negative part of the addendum is they added to that double bonded carbon atom which contain less number of hydrogen. So Markovnikov rule is based on this reason, and this is called the mechanism of the reaction. So in exam you may get the question, write the mechanism of Markovnikov addition. Then you have to write like this.